Hello, everyone. It's a pleasure to be here, and it's really an honor to be able to participate in Software Testing Day. Exactpro was founded 14 years ago on 9th of September 2009, and we focus on providing software testing services mostly to financial services, infrastructures, to exchanges and clearing houses across more than 20 countries. We do have quite a lot of information on Exactpro YouTube channel about software testing, about software development, artificial intelligence, high availability systems, and many other interesting things. Please do subscribe and visit our YouTube channel. You will find lots of interesting information there. So, in order to waste money on stupid something, you need two things. The first thing is money, and the second is something stupid. To ride a mountain bike, you also need two things. You need mountain bike and ability to ride. And to use AI in software testing, you need, first of all, you need AI, and then you need to actually do software testing. Because often when we describe different processes that rely on data processing or machine learning, they are not really software testing. So how to define these two terms? The first one is easier. European Commission have all the answers about what AI is. The second one is more difficult. I wasn't really going to dig into this topic, but yesterday there were several strange definitions on the subject, so I decided to cover this topic as well. So, software testing is not just about bugs. Well, in this case, I expect to hear massive booing because you are software testers and you should know that software testing is only about bugs. Software testing is finding and describing defects. Everything else is probably not software testing. Yes, software testing is empirical technical investigation of the system or a process or service under the test with intent to find defects. And everything else is not software testing. But yes, so software testers are people who provide software testing, and their responsibility is to provide information service, to provide information. The outcome of software testing is information. And the quality of software testing can be measured how accurate, how relevant, and how efficiently obtained this information is. Okay, but can software testers also write requirements or develop code? Software testers can do many things. So they can raise kids, or they can cook dinners, etc. But when somebody is doing something like that, they can be a caring mother and wife, but they're not doing software testing at that point in time. So software testing is activity that is related and fully focused on finding and describing defects. Software testing is not quality assurance, and software testers are not responsible for the quality of the product. There's no such thing as collective responsibility. Everyone is only responsible for their own actions and for the things that they can control. Software testers have ultimate responsibility for the quality of their work. So for the quality of the information that they provide. So how accurate is information? Whether it was delivered in time? What was the effort to obtain particular information? Software tester is responsible for this one. Software testers, most of the time, are not responsible for hiring software developers, organizing the teams, organizing requirements. That's why most of the time, they do not have responsibility for the quality, and they are not in the business of quality assurance. Software testers are in the business of providing information. And this, apart from necessity of doing it, it also requires responsibility for your own work. And this is one of the main reasons why AI is not able to test by itself. Because AI has no responsibility. But on the other hand, if you work in real life, you know that there are many people who also show little signs of responsibility. So maybe what is the difference between humans and AI? So there are plenty of irresponsible humans. So maybe humans also not able to test. Well, there are some benefits of dealing with humans. So with humans, they can be reasoned with. They can feel pity, remorse, or even fear. So you can scare somebody, if they are human, into acting responsibly. It is not possible to scare a computer into doing anything. And that's why people are able to test, and computers are not able to test. By extension, it also leads to a more precise definition of what test oracle is. So test oracle is not expected results or ability to produce expected results for the test. Test oracle is a classifier, not even classifier, but a function that defines the importance of calling a human to look into something. So when you do software testing or when you experiment with the software, computer program, AI system should calculate or estimate the probability that it should call a human and attract their attention to look into particular thing. Because quality is value to somebody. Quality is always subjective. And computer is not a subject. And most of them have no empathy. And they all have no responsibility. Only humans have responsibility. That's why when we develop test oracles, we need to think about them as a function that will calculate the probability. So if you see like HTTP 500, then the probability of, say, not probability, but importance of calling a human can be like 99.5%. If you see something else, then it is different. So when we think about AI systems used for testing, we need to think about them as something that will calculate probability, importance, weight of involving human into the process. But still, it is possible to leverage AI technology to support software testing. There are once again two things why there are substantial advances in machine learning that affect most of the industries and most of the sectors. It is the growth in computational capacity, and it also the growth in the volumes of available data. And due to these two trends, it is possible to obtain interesting results in all sectors using sub-symbolic AI and machine learning. And of course, it is possible to try to use the same technique, the same approach in software testing. Software testing can be structured in a number of steps. The first step is we are trying to figure out ideas for our experiments. So make a list of actions. Then we need to execute these experiments, these actions against the systems under the test. And then we need to evaluate our observations and try to interpret what we see, whether we believe that something that we see is due to a problem, that something that we see can reduce the value of the software or of the service to important stakeholders. And across these three pillars, the middle one, test execution, is mechanical, and it's solved in most of CI/CD pipelines. So it is not something that is difficult, it is easier. On the other hand, two things, designing or generating test ideas and interpreting the outcome requires cognitive effort. And the one on the left, generating test ideas, has medium cognitive complexity. The one on the right, interpreting the outcome, has high cognitive complexity. It also requires empathy, because you need to interpret whether something is a defect or not a defect. A defect is anything, anywhere that decreases value of the software for good stakeholders or increases the value of the software for bad stakeholders. So in order to interpret the output of testing, you need to have empathy and to be able to understand what represents value for other humans. To use AI, to leverage AI in software testing, you need to convert everything into two things, into zeros and ones. So the benefit of using machine learning algorithms that were known decades ago can only be achieved if there is enough data to deal with. And enough data can be obtained through two ways. So maybe it is possible to collect enough data, or maybe it is possible to generate enough data. And in software testing, in order to leverage machine learning, we need to deal with both approaches. We need to have lots of data. And the second thing, we need to structure the data in a way that it will be easily accessible by data processing and machine learning algorithms. So the essence of machine learning is covered perfectly in the course available in YouTube by Casey Kazakov, dedicated to machine learning. And machine learning is labeling all the things. So when you think that you would like to use data processing in software testing or in any other process, you need to start with the question what you can label and what you would like to be labeled. And then if there is sufficient number of objects that you would like to put different labels on and do it repeatedly, then you can use machine learning for this particular thing. In practice, you need to start with looking at the test basis. So do you have protocol specifications? Can they be converted into machine readable form? Do you have output of the testing? Can it be structured in a form of a simple data set? So you have test library of some test checks. Can you structure it in machine readable form? And the simpler the form, the better. So of course, modern AI can read multifaceted data in different formats, but computational capacity that required to do OCR with the data. So you need more electricity to understand the data in form of pictures in comparison to the data in form of CSV files. So you need to organize the data, you need to structure it in the most simple format possible. And then try to put labels not just on inputs. So you start with the inputs, with the test basis. And then you need to design procedure to put labels on the output of the test. If you have enough labels in inputs and in outputs, you can turn many tasks into machine learning tasks. And the task of machine learning in software testing is to calculate the weight, the importance of attracting humans' attention to a particular area. So if we believe that something is wrong, we need to raise a bell in our code. And also, we always face a balance between how often and how intense we should raise this bell, and also what additional information we need to pick up from the system and to share with the humans. So humans, there is a book, Thinking Fast and Slow, and human thinking is split into two different systems. So two systems operate simultaneously, System 1 and System 2. Who of you have read this book? Okay. Sure. So System 1 is something responsible for most of our processes, like breathing, walking, eating, and it has very high performance. On the other hand, system 2 is responsible for what we usually interpret as cognitive abilities and conscience. And capacity of the system 2 is very, very limited. So using machine learning in software testing is to dealing with lots of data and decreasing the volume of this data and structuring the volume of this data into portions that can be processed by human system 2. And this usually is very, very low volumes of data based on how we as humans are structured. One more idea, so if there is not enough data for your testing, the best next thing is to try to generate the data, to generate synthetic data. The main problem with generating synthetic data is that there are no theoretical limits on how many, on the volumes of data that you can generate. So if you produce test cases, test scripts using some software, you can produce millions or billions of these test cases. So the question of how many test cases do we have is no longer relevant. So the first problem with synthetic data, you not just need to produce it, but you also need to discriminate in synthetic data to keep only subsets of data that is useful and efficient. Synthetic data has the following four characteristics: is fidelity, utility, privacy, security, and explainability. So fidelity is how much synthetic data produced for any reason, for example, for testing, represents real data. And utility is how useful this data to perform particular function. In software testing, utility of the data means whether it helps us to detect and describe defects. So if we produce data that is not like real data, but it still helps to identify defects or describe them better, then this synthetic data has utility. Of course, privacy is extremely important and security. So you do not want to cause harm with the data. And explainability, we go back to system 2. So humans have limited cognitive capacity and computers capable of producing huge volumes of data. So explainability is whether we are able to understand and interpret generated data. In practice, there are many methods of labeling data. Some of them were mentioned yesterday, for example, property testing. Property testing is when you expect that the output from your software will match two particular properties. It is when you are not able for a complex system to fully describe its behavior, you can still assess particular properties. For example, for very simple scenario of sending requests to the web server, we might not immediately detect what responses are required for each request. What we can detect is return code. So return code is an easy property, and we can say that we do not expect to get internal errors. we do not expect to get exceptions in the logs. Or, for example, if we are dealing with financial application and we have the amount of money in the account, we expect that it should not fall below 0, etc. So these are simple properties that can be assessed. And what you do, you go through all the output of the system, structure it into the list of transactions, and then you use property testing, property check, to assign several additional labels to every record. So if you annotate test bases, you can then generate test cases. When you generate test cases, you can put labels onto these test cases. Then you execute these test cases, you take all output, and you assign labels to the output. Well, let's go quickly. Another approach, also mentioned yesterday, is to have a digital twin for the system. Digital twins are to a degree expensive, but they can be used to better assign labels in comparison to the system itself. You can also use metamorphic testing. There was a very interesting presentation yesterday about metamorphic testing. So the idea of using metamorphic testing for assigning labels is that you take the source test case and you have a number of labels produced for the source test case. And then you do transformation of the source test case that keep metamorphic relations intact. And metamorphic relations can be also described as the relation between labels obtained for every particular test case. If it is the case, if it is our case, we can produce lots of scenarios. Then we can transform them one after another and get a huge list of labels that we can use for data analysis. So using machine learning in software testing is labeling all the things: inputs, internal states, outputs. And then looking at this volume of data, trying to find a pattern, trying to find the weight of the function that defines that humans should look into this area. So there are more information about this and other things available on Exactpro YouTube channel. Thank you very much for your time.